I don't know what's happening. I think the stream should be live. Hmm. 1 minute. Your audio is fine. It's fine. It's fine. I think it's going fine. I'm gonna close down. Okay. Aniket, your first person is trying to join already, so I'll let him in. Okay. Someone's trying to join. I'll let them in. Multiple people are trying to join. I'll let them in now. At 4, we're starting at 4.
शख्सियत के बारे में बताने जा रहे हैं। पहले नंबर पर ना तो अमेरिका के सदर डोनाल्ड ट्रंप हैं और ना ही पहला नंबर मलका बरतानिया का है। तो आखिर है कौन पहले नंबर
हेलो। हेलो। Yeah, so hi guys, welcome to the Docker session. We'll just start in like 5 minutes. Yeah, so once again, hi guys, welcome to the Docker session. So before we start, just a brief introduction about me. So I am Aniket, currently in sixth semester BTech Computer Science and Engineering. So I interned at PES Innovation Lab in 2020. That's just after my first year in the summer, and will be interning at Walmart in the upcoming summer. I am interested in web development and Linux, and like for any talks about Linux, you can always find me up. Yeah, so let's start. Also, just to mention, we shifted from Teams live meeting to this meet just in order to keep it interactive. So just feel free. The main aim of having such sessions is to like you can interact as much and get all your doubts clear. So feel free to stop me anywhere, ask anything or whatever you like. Yeah, so let's start. So before starting, the first question that comes is what is a Docker container? Basically, we are uh, gonna handle Dockers here. So what is exactly a Docker container? So before we answer that question, we need to know what does it replaces. So Docker containers actually replaces virtual machines. So let's see about the history, how it goes. So basically, traditionally before VMs were introduced, what would happen is we will install a single operating system on any piece of hardware. Let's say we have a typical server. So this is a traditional server. So basically, we'll install a single operating system on this entire server machine. So that operating system will get all the resources. That is all the CPU that's available, the RAM, the hard disk, all the resources were dedicated to a single OS. That is one server OS. So let's say we install Linux on this machine. So Linux will be, as I told, Linux will be acquiring all the resources that's present on this server, and basically we can call it as a Linux server. Same way, if we install Windows on this server, it will be a Windows server. So what is the issue with this approach? Like earlier, why we needed to change, why virtualization came into picture. So initially, we can say that there's no issue, but the issue arises only when we need another server. Suppose we have a single machine on which we want both the servers. We need Windows for some task and we need Linux also for some task. Now is the issue because since we were installing a single operating system on one machine, we were not able to, like if we wanted like two machines will need if we wanted two operating systems we'll need two machines in order to install them on. So basically before VM, if you wanted a Linux server and a Windows server, we'll get two of such physical machines, install Windows on one, install Linux on one, and get in running. So that's a problem because it's a very heavy hardware spec, and basically if we can't render multiple parts of it to different OS, that was an issue. That's where virtualization came in. So in virtualization, what we do is instead of installing a single operating system, or let's say like the single operating system acquiring all the resources that are present on the server, we install something known as a hypervisor. Now, what is hypervisor? So it's a kind of operating system, but the only difference is it's completely dedicated to achieving a single goal. That it helps the user in order to carve up or divide the server resources into multiple servers. Just a second. Yeah, so uh, instead of installing a single operating system, we installed a hypervisor, which has that's also an operating system that has a single goal. It helps us to carve up or divide the server resources into multiple servers. So basically, before we had virtualization, one operating system occupied all the resources. But now, if we have a server, we can install a hypervisor on that machine, and let's say we allocate some resources to one machine. Let's say we have a Windows Server 2012, so we are allocating one CPU, 2 GB RAM and 40 GB storage. So that's our Windows Server. On the same machine, we can have Ubuntu as well. So it has 4 GB RAM, 100 GB storage, and 4 CPUs allocated to it. So yeah, this is how virtualization came into picture, and at that time it became very famous. Now, there are many famous hypervisors. As I told, we will be using a hypervisor. So some examples could be Proxmox, libvirt, and VMware ESXi. VMware ESXi is a popular one generally used on server, which stands for Elastic Sky X Integrated. Also, hypervisors are generally of two types. So basically, we classify them as type 1 hypervisors and type 2 hypervisors. Type 1 hypervisors, as I told, they are installed on the bare metal. So basically on this server, the only thing that will be running will be that type 1 hypervisor. And on that, we will be running our different operating systems. So we will install Windows alongside, Ubuntu alongside, and that hypervisor will allow us to distribute the resources among the two so that both of them can run parallelly. Other type is, I'm sure you are familiar with, everyone has used it, that is there is a host system on which that hypervisor gets installed, and then it allows you to do virtualization. The best example would be virtualization didn't came into picture. We are again gonna do the same thing. We are gonna install a single operating system on the entire server. So again, that one server OS is gonna get all the resources of the machine, whatever RAM is there, whatever CPU is there, all of that is acquired by a single machine. But the question is why we need to do that. So the answer to this question is basically, if we I have to differentiate Dockers versus VMs in single line, their working principles differ by just a single factor. So basically, virtualization and the virtualization and VMs allow us to virtualize hardware. As we saw, we can divide the hardware among multiple VMs. Here, the Docker virtualizes the operating system itself. So now, what does it mean by virtualizing the operating system? So let's take an example. So on the left part, we have the working for a Docker container. Sorry, on the left part, we have the working for a VM, and the right part, we have it for the Docker container. So let's consider a VM. How is it working? So we have the bare metal hardware here. We are going to install some hypervisor on it. So let's say for our case, we have installed VMware. Now, once we install the hypervisor, it will allow us to distribute the resources. And basically, we can have a Windows server, an Ubuntu server, CentOS, and Debian, all four running on the hypervisor itself in parallel. Now, how Docker container works. So on the Docker containers, we have hardware. And as we told, we will have a single operating system that's acquiring all the hardware. So suppose we have Ubuntu installed on this, and it's acquiring all the hardware that's present. Now, what is a Docker? Now, Docker comes into play. So, Docker is just like any other process on an operating system. It's a process or a daemon that is running on that operating system, and it helps us to virtualize the portions of our operating system in order to create what are known as containers. So, we'll have a Docker engine that's installed as a process on Ubuntu. It's running, and now it will allow us to create what is known as container. So this is a CentOS container. This is a Debian container. This is a Ubuntu container, and Hence, we are able to virtualize the part of our operating system using that. Now the question comes is what are containers itself? Because we haven't defined containers yet, right? So if I have to define it in the simplest terms, containers are super fast, lightweight microcomputers that can scale up to infinite power. So I mentioned three terms. I'll be explaining all of them. Like they are super fast, they are lightweights, and they can scale up to infinite power. So basically, containers have their own operating system. They have their own CPU, own memory network, as in the case of a VM, and they are also isolated and secured. So basically, as far as they know, they are the only thing that's running on the machine. If you're going to ask this Ubuntu container that does it knows anything about Debian or CentOS, it doesn't, because both they are completely isolated. They one of them doesn't know of the presence of the other. So now the question comes to define the terms, like what is why are the Docker containers fast and why are they lightweight? So why are they faster than a virtual machine and why are they lightweight? And the third question I'll be answering is where is industry using it? So let's see the reason why their containers are fast and lightweight. So reason for that would be it is so fast to like we'll see we have the hands-on session, so we'll see why it's like how fast enough it is. So it's fast to create as well as boot because we need a single kernel. Yeah, so we need a single kernel in order to use Docker containers. Now, what does that mean? So basically, if we go back to the image, we have CentOS installed, Debian installed, and Ubuntu installed. What they are doing is all of them are using the kernel of the existing Ubuntu distribution that's there. So basically, the host OS, the host OS, the kernel that is running, the same kernel is going to use by all the containers that's running on the machine. So this is CentOS, this is Debian, this is Ubuntu. All of them will be using the underlying Ubuntu kernel that is there present on the host operating system itself. So now, since both the questions basically get answered since the kernel is already up and running. Whenever we are booting a VM or we are installing a VM, each of them will be running their own kernel. So Ubuntu will have its own kernel going on here, and then it will be running Ubuntu client on that machine. On the other hand, since they all of them are using the same underlying kernel, and since you are using the host OS, the kernel is already up and running for this Ubuntu. So if I want to, let's say, create a new container for Debian, what Debian has to do is just has to get the basic packages that are there for package management and all in for the Debian distribution, and it's done. It doesn't has to get the kernel. That's why it becomes lightweight, because the kernel is the heaviest part of any operating system that we need to use. Since it's not there, we just need to get some basic packages in order to get Debian running. That makes it lightweight. And it's fast enough because the kernel is already up and running. The time to set up the kernel and getting it running up is the major part of what it takes to boot a VM. So basically, since it's already up and running, it can directly send requests directly to the host kernel and it can get it processing. So that's why they don't need one more than one Linux kernel to operate. And since they are each of them are all of them are sharing the same kernel, there's the requirement for just a single kernel. So that makes them completely lightweight. You don't have a separate kernel that's taking space and a separate kernel that's running for each of the operating systems. Now is a question for you guys. Thinking about the use the underlying kernels and seeing these two images, could you guys point out a difference? There's a small difference between the two diagrams, basically. Uh, can you guys point it out what the difference is? It is based on the fact basically that it uses the underlying kernel that's there for the machine. So you can try, no issues with like, is it wrong? Its side doesn't matter. Like, can you see there's a very small difference? There's actually just a single difference between the two of them. Okay, so let's see what the difference is. The only difference here is you can see these three containers, these three VMs running, these three containers here, but Windows is missing, isn't it? There's a Windows server that's present here, but Windows is missing on this end. Now, why is that? So basically, Windows is not present because we can't install, as we told, it's using the underlying kernel. Since our host operating system is running basically Linux distribution. So the Linux kernel is up and running. So we can't install like we can't use a win we can't create a Windows container on a machine because it won't be able to use the underlying kernel that's for Linux. So that is an issue basically, that on a Windows you can create multiple machines, but all of them can run some version of Windows because they will be using the underlying Windows kernel. Same way on a Linux machine, you can create containers that are running Linux itself. You can't use Windows on that. Now, if you'll Google or you'll see on Stack Overflow, you'll find many answers like how to get this container running, like a Linux container running on Windows or something like that. All of them in the end fall to the same principle. They are getting the Ubuntu base image or some other Linux distribution base image ready on their Windows. So basically, they are getting the kernel itself that to be up on Windows, and then they are installing containers. So in the end, they are again getting this layer. That's the base image, that's not the proper installation, but they are getting it, and then finally on the top of that they'll be like installing or making containers of Linux distribution. So that basically essentially does the same thing that's here. But just if you want the Linux container to use the kernel of a Windows system, it can't. Same the other way. If you want like a Linux container to use the underlying Windows kernel, it can't. Both of them are different. Yeah, so basically this is one of the issues that's there. Now the question is, why is it like so famous? Why are Dockers used everywhere? Where is industry using it? So uh, where is industry using it? So there's a small meme that's very popular everywhere. Like one guy is saying it works on my machine. The other is like, since it's working on one machine and not the other, they are basically trying to ship their machine. It is machine itself. Like it works on your machine, will ship your machine itself. And they call that is how Docker came into picture. So basically it's a very killer tech for developers. Basically they can write their own code, deploy it in a Docker container, and they know that if the way it works in a Docker container, it's going to work everywhere the same. Earlier it was like it might work on one machine, you are putting a lot of effort in installing stuff and everything, but later it is not going to work. So everyone is like it's not working, and you are like, I spent so much time, everything is working on my machine, why is it working on yours? So that is the main thing why Docker came into picture. And yeah, after we have seen the theory points, how it works, what are the basically differences, now we'll see it in picture and get like our hands dirty, and will all the theory points that we have discussed will be seeing those things live on hands on. So yeah, just to mention, I'll be using a VM to show you the installation procedure. Meanwhile, I get my VM started. You guys like can go to Katacoda and have an account if you already have one. Like it was told to get an account on Katacoda for the.
Excuse me, one doubt. The containers you told, we can have only those Ubuntu and Debian, or can we have others also?
No, no, we can have any container. It depends on the image. Like, wait, I'll show you just a second. There are many images you can have, and basically it has more variety than you can have for some virtual machines because they need to run a full desktop environment, right? So there is a repository known as Docker Hub. We will be using images. Don't worry, I'll explain that. If you just go to Docker Hub for a moment, you can see all the images that's present on Docker Hub for usage. Just a second. I think I had it logged in on the other ID. Yeah. So basically, this is the exact main repository from where whatever you're gonna install, maybe it be an image or anything, that is located at a central repository called Docker Hub. Whatever commands you give to fetch images will be taken from here. So you can go to repositories and yeah. So here you will get also see we can see like what all is there. So we have an Ubuntu image. We have Redis, we have Node. You can have a container that's just running Node. You don't need any operating system, nothing for that. You can have something that's running on MySQL. This is just a test program. We'll be using that to check our Docker installation. And then you can have anything like you have Alpine, you have BusyBox, you can just run a Python container, Postgres. So there are many containers which you can run specifically for some applications as well. It doesn't need to be like a whole system to be installed. So you can see there are many. Even if you want to use Rust, you can directly get a Rust container and get going.
Okay, thanks.
Cool. Yeah. So I was telling, just go to Catacode and get an account if you already haven't. So if you will search Catacoda, you'll get this Ubuntu playground here. Actually, I'll put the link in this as well. So here you'll be asked to the login thingy. You can sign up with anything like LinkedIn, GitHub, Twitter, or you can just enter. There are only two fields, so it's yeah. Like take 5 minutes and get it done. So we'll be doing our hands on there because it's gonna provide us a virtual machine. So we don't need to like figure out about the dependencies and all. We can directly get going. Meanwhile, the first thing that I'm gonna deal is showing you the installation based on how you can install Docker, just referring to the docs. So I'll be getting a VM started for that. Meanwhile, you can register for the Docker Hub account. Sorry, for the Catacota account. Yeah, cool. So hope you have registered. So basically, again, the installation procedure basically changes for OS to OS. So I'm like currently, if I talk about my host OS, I'm running Arch Linux. So basically, uh, on Arch Linux, if I have to do it, it has something known as an Arch user repository. So basically, that's a repository from where you can pull any package, and that's there, and you can install it as a application on your machine. So for if we have to install it on Arch OS, the process is going to be very simple. I just have to go to App Store and search for Docker. So we can see like Docker is already installed. So and all the other things like Docker, Docker Compose, whatever is there is directly available on the App Store for Arch Linux. But since most of you would be using like a Debian distro or mostly Ubuntu, basically we're gonna see how we can do it here. So just to get started, basically we have to do nothing. We just have to check the instruction guide. Docker has a very proper instruction guide for installation. So how we are gonna install it completely depends on the operating system we are using. I'm just gonna search for installing Docker on Ubuntu. So just install Docker on Ubuntu. Yeah, so the first basically result that you're gonna get is the docs itself from Docker, how you are gonna install, and you just have to follow the commands. It's nothing more than just basically copying the commands and pasting it to get it working. Yeah, so there are some requirements like for the support version, although it's supported till 18.04, so there won't be any issues. Most of you will be running like a version above that. So yeah, you just have to go to the command. So first, just to get our repositories updated, we're gonna do sudo apt update. It's just gonna update the repositories that's there. Then these are the requirements that are required to run Docker. Basically, these are like a dependency. So we're gonna install them first. Yeah, so now you can go ahead and like install the dependencies. Just a second. Okay, so the background
Excuse me,
updater
this
is
we should install on Katakoda.
no. That will be there. I'm just showing you a demo. If you need to get it working on your host machine, how you can get it there. There, like if you would have opened the page, it would already give you a virtual machine with like a command line on the right side. So if you check Docker version, it's already installed there.
Oh, okay, so we don't need to install.
No. That's installed. It is just like on your host machine, it won't be. So basically, if you want to like use that on your host machine someday, so basically you can how you can install. That is what
But
I'm
I
trying
have
to demonstrate.
Windows.
So Windows, you have something known as like Docker desktop. Although like Dockers and the Windows doesn't go that well. Like it's better to for dev work to stick to basically Linux. But yeah, if you want to, you have something known as a Docker desktop there. So if you check Docker for Windows, you will get it. So how you can install on Windows? Basically, it has an application itself, like Docker Desktop. So here you will just get like an installer. You need to install it and like start the Docker Desktop. So you'll get something like Docker Desktop here, and then you just need to start off. Then it will be automatically guiding you how to go ahead, and it will install everything for you. Just a second. Can we WSL and need VirtualBox? Like again, if you want, you can emulate, but basically the main thing is you might run into some issues here and there on Windows. Basically, there are very few people that like use Docker on Windows. It's way better to use Linux for development work. Anyway, you are like most of you will be doing development, so Windows is not a go-to place. Basically, you should stick to Linux because anywhere you will go, you'll see the containers. Also, most of the containers that are deployed will be running Linux itself because it has like many tools for it has many tools available by default for the developers, so that's why they like basically the developers like to use it. So basically you would have like use a C program or something, right? You will have run into something like seg fault. On Windows you won't even see it. The terminal will just terminate. Moreover, if you are curious enough, you can search something known as sanitizers. So basically there are sanitizers present that can basically check if where the memory leak is getting and all, and they can inform you more about that. Just a second. Okay. So basically the background updates are running, so it has occupied like a lock on the same app which I'm trying to use to install. Just 1 second, let's see if I can disable it. Okay, never mind. So let it be on the background. I'll show you after we do the commands. Let it install on the background. We can switch to Katacoda for now, I guess. So yeah, so we can go to Katacoda. So this is like this you can follow off because basically all of us will be using the same platform and it has it installed. Make sure you use the link that was there in the chat or the Ubuntu playground because it's like easier to see everything and it doesn't like has some task assigned. So basically you don't have like many windows open and all. It's good. So once you come to the website, it's gonna take like 4 or 5 minutes. Yeah. So yeah. So as one of the questions were there, we can check like if is Docker present already. So basically we can do a Docker -v on any system to check what is the version of Docker. So we can see yeah, Docker is working. It's like version 19 is installed. So basically getting used to some basic commands that Docker has to offer. So in Docker, what we use is what we use is are known as images. As same as like for the virtual machines, we have an ISO that gets it installed. So the files or the dependencies that's present for the running a Docker container on that thing is basically known as images. So you can again go to like Docker Hub and you can check off. So basically on if you go to the Explore tab, it will show you like all the images that are available. So we can like pull in any image and get going basically. So if we check like an Ubuntu image, so if once you open that, you can get like additional documentation and some commands that you're going to use in order to get it on your system. So we can see like there are multiple versions. So these are called as what are known as tags. So what we do whenever we are specifying, like if I have to pull like Ubuntu focal, just in case. So I'll go to the playground. The command would be to use docker pull and then the image name. Now in image name, you have two parts. One is what you want to pull, the name of the image, and one is like a version number, which is called as the tag name. So that tag name specifies exactly which version you want to pull. And basically it's mentioned by default here, and you can mention like any of them, this, whatever you want. So basically it's easier to use name because people don't remember the versions. It's generally easier to mention like focal or whatever. So let's try focal. So what it's gonna do is it's gonna go and check for the similar thing on Docker Hub. It will find this thing and then try to pull it from there. Not sure why it's taking so much time. Is it like did any one of you got it pulled by default?
Yes, for me it's showing full complete.
Sorry, could you repeat?
It's showing full complete.
All right, not sure what is the issue. Just a second, we'll try refresh. Yeah, so let's try again. Not sure why this is happening. Okay, now it's working, I guess. So yeah, once you get it, so basically you get an image with that specified tag. So you can see you got Ubuntu Focal. Now, uh, to check what images you already have, like what once you download an image, it just is generally saved on your PC because all the contain basically like images are blueprint for containers. They use that blueprint in order to create containers. So the containers on the end basically underlying they're using the image. So we can use a container for something like if we are having a container for Ubuntu Focal, you must have that Ubuntu image in your system in order for it to function, since it is using that as its core. So basically in order, if you want to check like what images you already have, you can use a command known as docker images. So it shows basically which images you have. Some of them are like by default. So we can see like Redis Alpine is a very lightweight operating system. You can see it's hardly 4 MB. So that's by default there. Ubuntu latest was already there, in like it's already present for the lamp. This is the one we pulled, like focal. Uh, and you can see the size. One thing to notice, as I told, they're lightweight. If you have a Ubuntu basically virtual machine, it's gonna last from like 2 to 4 GBs depending on like which kind of these things you want. They are like hardly 70 MBs because they don't need to get the kernel downloaded up and running. It's already there. They just have some basic packages that are needed to support Ubuntu. Now, in order to like basically, if you just wanted to remove an image, just suppose I want to remove Alpine, what you could do is Docker image rm, specifying that you are trying to remove the image and Alpine. So we can now, if we check the again Docker images, we can see that basically Alpine was removed. So this is the way you can delete an image. Yeah, make sure before you delete any image, there should be no container that's using it. Basically, there shouldn't be any container that's using that image because otherwise you won't be able to delete. First, you need to remove that container, then only you can remove the image because the container would be using it at its core. So you can't remove the core while the machine is still there. So basically that's there. Now just to spin up a Docker container, if I want to like run the Docker container, the main thing. So I'll clear it. So the main command would be what we use is docker run hyphen d hyphen t hyphen name. I'll explain what each of the terms is. So like you can give any name and then the image that we're going to use. That is the basic version of spinning a Docker container. So for the starting, Docker run tells like we want to spin this image. This should only be run the first time you are creating a container. Once a container is created, it's already there. So you can just start or stop it. But since we don't have any containers currently, so for creating a container using an image, what we could use is Docker run. So Docker run, this hyphen D stands for detached mode. So what is detached mode? Basically, if you don't use that flag, what will happen is it will spin up a container and directly get you inside the terminal of that container. Basically, you will be inside Ubuntu running this focal version. So to avoid that, you use detach mode. So it will just start the container. It won't take you like directly to the shell. So that way you can see like the container was started properly. The container hash ID that yeah, this is the ID, and then you can connect to it using another command. Then hyphen T stands for like terminal naming. So basically, if you don't use, what will happen is whatever terminal name is there on your machine, like if I open my machine, like if I open a terminal on my machine, what it will specify would be a name, right? Like on the left side. So it's Aniket at something. So if you are not specifying the hyphen T type, what will happen is this Aniket will just get replaced by root. So it becomes a little confusing. Like, are you in the host OS or are you inside the Docker container when you are running commands? So this hyphen T commands make sure that the name gets randomized. So then it will be root at your basically the Docker containers ID. So that way you can easily differentiate. Okay, I am inside a Docker. I am inside my host OS. That hyphen name is just a name for a container. Basically, if you don't provide a name, some funky names will be chosen automatically by Docker. So you can just give a name to the container. So I'm just naming it container. And then this is the image that you want to use. So we are using the focal image. We just download it. Yeah, so let's do it. So we can see this is the time that's taken to spin up a Docker container. It hardly didn't took a second. It didn't even like took a second in order to basically get our container up and running. On a VM, booting a VM takes more time than this because the kernel was already like up and running, and we can easily like just get the environment set up and we are done. So now if you want to see like basically anything like what containers are already running, so you can use a command known as docker ps. That tells you information about the containers that's running, those which are running. So basically this is your container ID for the image that we like already created. This is the name. Basically we have container as the name for the Ubuntu focal thingy. This is the command. This basically tells you what is the process that is running inside the Docker container to which you can connect to. So basically here it's bash. Basically all of them will be running bash cells, right? So you can just connect to it. It's like created 36 seconds ago, and the status it's up for how long. Now what we want to do is we got our container up and running. We just want to connect to it. So what we could do is docker exec, so that it stands for executes, hyphen it. This is an important flag. If you miss hyphen it, basically you will be like going to the docker container, but you won't be able to execute commands because it won't be interactive. So it stands for interactive terminal. Basically, if you want a container that is like that responds to the command that you enter, you must include this flag. Then the name of the container. So for us, it is container itself, followed by the thing to which we want to connect. Here we want to connect to bash, and done. And that is how you are now inside a Docker container. The hyphen T thing that I mentioned already. So you can see that the name is not now the normal one. It's a name that's randomized. So it makes it easy in order to differentiate. Also, one more thing to notice, by default in any container, you have the root access. So you are by default the root. Yeah. So till here, like you have any questions? Feel free to ask anything.
Yeah, actually, I wanted to ask, means as we are creating containers and we are giving it names and assigning and getting a particular bash or some work done.
Yeah.
So, what's the use when we can just do it with a normal program? Means like a Python program or any other normal program which will be executing within the system.
So basically this is isolated. So now you can manage your dependencies, right? Basically you are inside a container. So that container means you're just like a VM. So currently we are using one container. You can have like two containers and containers that all of them running in parallel. So just suppose I give you a use case, okay? You have a project that's using like basically two or three versions of the same software. Suppose for one thing you need like, let's take Python. You need Python 2 point something just in case, and for one thing you need Python 3. So then it's fine, you can install Python 2 and 3 separately. But what if you want like two different versions of the same thing which have like a conflicting dependencies? You want to run like suppose Python 3.8 and 3.9 on like the same system at the same time. How would you do that?
Okay, I
Yeah, they will
understand.
be conflicting, right? Basically you can do it because it has an issue. Basically you have conflicting dependencies, both of them, like something needs some version of them. Let's suppose it has a dependency on say like there's an app whose version 4 is needed by one of them, another needs version 5, and both of them are conflicting. Like one is like, the successor of the other, so you can't get it working on the same machine, right?
Yeah, I understood.
Yeah, now what you can do here in such a case is create a two containers. Basically one container that's running one version, because we'll see now we have just entered the container. Anything like this container is completely empty, it has nothing. So you can install something on one, something on the other, and basically you can just get going, nothing to worry about. Basically if you want to access them, you can just expose them to a port on your machine. We'll see how to do that, like exposing files and exposing ports. So you can just expose them to a some port and done. Basically you can have two ports which are running different versions of the same thing. It follows this from the same point that the containers are basically isolated from each other. Second point would be doesn't pollute your global namespace. Suppose if you are using like you are trying something risky, you're installing something, it has like adding many PPAs or something, then it's an issue again, right? Basically because if you like screw up in between something, your system is gone. So what you can do is create a container and go through the entire installation process inside it. If you mess up anything, like anything get messed up, it's just a single command to get it removed and get another container running.
Yeah.
So that isolation makes it very easy. It's serving the same purpose as that of a VM, but basically it's way lightweight, way faster, as we saw. Like by booting the VM earlier took more time than basically creating a container and getting to it. Yeah. So any other doubts?
Yeah, I have a question. Uh, that while using these containers for data science.
Sorry, couldn't hear you. Like there's too much background noise. Could you be a little loud, please?
Yeah, yeah. So I'm asking that using these containers for the data science projects.
Yeah.
So it is, yeah, often said that we can use containers for storing our codes for various like feature engineering or whatever is there.
Yeah, you
So
can
can
get
you
them separated. Yeah.
explain how to do this using these containers?
Sure. We'll go through the installation step. It is just like we just got to a container. We have many things
Hmm.
in which we will be like installing dependencies and showing you even some like other ways. Currently, I've seen like Docker works from itself from terminal, right? Like
Hmm.
it comes as a part of a continuous deployment. So basically, what you do is you just basically get everything running and deploy on these containers because these containers are scalable enough. If you want, you can scale them anytime. So one container can replicate to 10 run doing the same job and all. So generally, they are used for deployment. Whatever development you have to do, you do it on a host machine and then just like running or getting things exposed that you do basically on the container itself.
Okay, okay.
Yeah, and we'll see. Yeah, we'll see the installation steps. It's just the like currently we are just going through the basic commands in order to so that you know how to like start working with them, how to get a container, start a container. So once you are done with that, then you can go ahead and install anything.
Okay, okay, sure.
Cool. Any other questions?
Yes, I have one question. So,
Yeah.
essentially, a container, you can treat it as a separate machine in itself and be able to run commands in it with its own dependencies installed. Now, to what extent can you treat it as a separate machine? Like, can you say it can have its own network?
Yeah. It
That's
has.
it.
I mentioned that point. It has everything of its own. It has its own CPU that's attached. So, okay, let me introduce you to one more command here. If I were to run Docker stats, so that is like the stats for what is going on. Sorry, status. Just a second. Oh, I'm inside Docker. Lol. Never mind. So I'll just exit it. Yeah. So Docker stats. It will show what is going on with this. Just a second. See. So you can see already that what is the network IO that's working, how much it is using of the thing, what is the block IO that stands for disk thingy, how much is it using, what's the CPU percentage, what is the RAM usage, what is the limit that has been allocated, what is the percentage utilization, and everything is managed by itself. We don't need to take care like a VM because we told right in VM we are virtualizing the hardware itself. So we need to tell how much hardware we are virtualizing. These containers are scalable based on the load. You can see currently it's using 988 kbs. That's it. The entire container is running just that. As soon as you like start something, like you start a server inside, you get something running, it will automatically scale, and they can scale up to even the full like the full capacity that the host was has to offer in order to do your job. So they automatically handle these things internally without like you needing to even know about them.
Okay, so I mean, I understand that one, but my
Yeah.
question is like this. So, whenever you create a VM,
Yeah.
the VM itself has MAC addresses. Uh, and so you can use VMs for virtual networks and stuff. Is it
Okay.
also possible to do the same with Docker?
Yeah. Actually, Docker also has its own IP and stuff that you're telling. So again, if we go to another command that is known as docker container inspect. If you go to docker container inspect and then name the container. So basically our container was named container itself, if I remember correctly. You can see all the things that's associated with the Docker thingy. That what are the networks that's using bridges. You can even create networks if you were gonna search, like if you want to use like different network than a host system or create a pipes. And as you mentioned, have a look here. It has its own MAC address here. This is the IP address that's running. This is the gateway endpoint network ID. Everything is available here, which you will get normally working on a VM. So currently there are no ports exposed, and you have like all the information. So Docker inspect is like giving you the entire file how Docker is managing things. So this is like regarding the CPUs, the memory reservation, how much swap is being used, what is the link. So you can have a look, like you have everything here. Basically, I could have shown you an example, but since this is a basic course that is like advanced, a little advanced stuff, you can basically create your own networks and get, like, get machines connected to. So that network acts as a pipe. You get two machines connected to that pipe, so both of them like have a separate communication. Even that is virtualized. Those machines think there is only a single network which connects those two, nothing else exists. That's it. And as you mentioned, everything is there present for a container as well.
So, what's the major difference between a virtual machine and a container?
So again, the same thing that I mentioned during the this thing. Where is that? So basically, yeah, just a second. This working is different. Basically, here what Docker is running is the Docker engine that's running. That Docker engine is not basically, some like a kind of an operating system or a hypervisor or something. It's just a process. It's just, we see, like we were installing, like we are going to install it on Ubuntu and show. So it's just like a process which can be installed on any machine, and using the underlying kernel, it creates an interface so that these can interact with this without knowing about like other container. This container is separate. You can assume it's like just it's a single virtual machine. This is another virtual machine. This is another virtual machine. It's exactly similar to that. None of them know about each other. None of them have like any issues or something of dependency, like, okay, if there is something I need to worry about this. No, all of them are independent. You can have as many containers as you want, you can install as many things as you want, and basically all of them will be isolated. And you can run like many containers in parallel. On VM you still get a limit, right? Basically you have very limited resources. I think 4 VMs is good enough to crash like good pieces. Here you can have like tens of containers running without like even a small glitch at your end. We'll see that again. We'll be running multiple containers to show that. So basically the main is difference is in working. And one major difference why Docker containers came into picture, as I mentioned, like where is the industry using it? The meme that was specified by this, I'll be showing you just after this. You'll be doing it yourself. That on a VM or something also, what you do is you install something, right? You tell, okay, I did this, it is working. So on your friends, same thing might not work. You might get an issue, you might get something else. On Docker, there's no such problem. Basically, if one thing is working at your end in a specific way, you move it anywhere in the world, it's guaranteed to work in the exact same way on all of your machines. We'll see a live example of this just after like 5 minutes.
Okay.
Yeah, any other questions?
You in the status one, you mentioned that Docker has every container has its own swap file as well. But isn't swap file more or less like something hardware related? Because I mean, it's
That's
not
not
really
a file.
hardware
It's
related,
just
but
the like space that it is using in order to keep something that's suspended. Don't take swap file as like which is it there in Hibernate or something. Anyway, containers are running, they are mostly that. You can just stop it and do it. So basically what it is like for if you are, you like, suppose your memory gets limited at some time. We saw, right, it was 0 bytes. So if your memory gets
correct.
like basically suppose this thing, you have like suppose 4 GB of memory and you are running enough containers in order to like even exhaust that. So what happens is, I told, right, like Docker is also running its own operating system. So since it's running its own operating system, it needs a way to support paging, right? Basically, it should have some way that if sometime, if the full like all the processes have already occupied, I don't have enough space and user is demanding for something, I should get the ability in order to like send something to the disk for some time, the disk that Docker has access to, keep that process there until the other thing is processing. As soon as it becomes free or is needed, load it back. So swap stands for that here.
So Docker has its own like small part of the disk, which
Yeah. It has everything. It has its everything that you have in virtual machine is there. It's just that it's abstracted from us. Again, to show, just a second. Docker stats. You can have, you see, like it has net, so that is for the network part. This is the block IO. That how much like input output you are doing. This block IO is what related to files. So that is also there. It has its, because it takes its space, right? Each container has some space that it takes. So that is there, and it is scalable. One more issue is in VM, if you have fixed it at 2 cores, suppose your app sometimes need 3 cores, or suppose the RAM dependency, you gave 2 GB, it's like overwhelming. Now you want it somehow to like extend it to 4 GB. You can't. You have to shut down the machine, then change the dependency, boot it again. Here it scales automatically. The limit and the usage will automatically scale up based on how need is. The only limit is the host limit, obviously, because if you have a physical RAM of 16 GB, you can never allocate more than that, right? So that is the only limit that is there. Otherwise, scaling and everything is handled by default. And basically, these containers are used way more than you guys will think. Hotstar and stuff, all the like deployment platforms. You would have seen the news, right? Like 1.5 crores user were simultaneously present and stuff, and without a glitch. It was because of Docker, because they're scalable enough. As soon as your needs go up, the basically resource occupation and deployment automatically goes up. You don't need to worry about or need human intervention for that. You just need to keep doing it. The load balancing will be automatically taken care by it. So is it clear?
Yeah.
Okay. Other questions? Okay, so for clearing doubt only, most of the commands I have shown you Docker pull to get like an image from Docker Hub to your machine, Docker images to list out the Dockers, a Docker PS in order to see what are the running. And yeah, one more thing, Docker PS has also a variant, like you can use a flag known as -a. It just tells you like all the images. So basically whatever, sorry, all the containers. So whatever containers are there, all will be shown. They might be running, they might not be running. So Docker PS is basically showing you what are the running containers, and Docker basically PS-a shows you all the containers. So currently it's running. To stop a container, suppose you are done with it, you want to stop it, what command you use is Docker stop and the container name. So we have named it container itself. So Docker stop container. So it will just let you know as a response of what was stopped. Now if you do Docker PS, you can say nothing is there. So basically none of the containers are running at now. Now if you do Docker PS say -a, you can see all the containers that were there. So although it's not running, it's exited like 15 seconds ago, but these are the containers you have. So it's a good information to know. Now if you suppose, like as I told, Docker run has to be run only while creating this thing. It has to be run only while you are creating the container for the first time. See, here we already have a container named as container. What if you want to use it again, right? Like if you want to reutilize it, what you can do is again just the opposite variant, Docker start and the container name. So Docker start container. So what it will do is it will again start the Docker container, let you know that the container has started. Now if you see it using Docker PS, you can see the container is again up and running. Now if you want to connect to it again, exact same command, Docker exec. Never forget the -it flag, otherwise you won't be able to execute the command. Then what is the name of the container to which you want to connect? It's container itself. And which process you want to connect? I want to connect to bash. Then you're again inside the container. So it's that easy to start a container, stop a container, get a container running. And suppose like my work is done with the container, I'm never going to use it. Again, you want to remove it. So just Docker remove, so RM for remove, and just the container name that you want to remove. Oh, sorry. Yeah, it's running. So make sure that like the container is stopped before you remove it. You can't remove a running container. So if you see Docker PS, it's already running. So you can do a Docker stop to get it stopped container. Yeah, once it's stopped, basically you can easily go and like remove the container itself. Oh, sorry. I pressed something else. Yeah, so it's already got removed. So basically now if we check basically Docker PS-a, we don't have any containers now. So it's that easy in order to get it done. So we basically, for now, we have just focused on two parts. Rest all is pending. We just showed how fast it is to create a Docker container, how easily we can do things inside that. Actually, I'll give some installation example now. And then how easy it is to like, get a container running, remove a container, pull images, how lightweight it is. Now, suppose we were again to like, just to show the installation, like since someone asked, basically, if we wanted to like use it for some task, like I suppose I want Python or something. So yeah, you can, I always go create a, basically, create a container. Let's suppose you are using it for some specific work. So you can create, like, if you have n things to do, create n containers for each of them. So container one for this task, container two for this task. Now what you do, so basically, let's get the container running. So docker run -d. Again, the detached mode and making sure the terminal name is proper. I'll again name it, let's say it's a lab, Python lab. That is mostly why everyone will be using it. And then you can just name the image. So here I'm going to use the Ubuntu focal image. Let's spin it off. We get a container running. Now we just need to connect to it. So docker exec, get the interactive terminal working. We are going to connect to, Python lab this time. And the process is again bash. So you are inside. Now you can do whatever you do with an Ubuntu, even on your Arc Linux, any machine, doesn't matter. You can do whatever you wanted to do on Ubuntu. So you can see, like, it has its own dependencies. There's one package that can be upgraded, and you can go ahead and install anything. Like, let's suppose I want to use Vim. Let's install Vim. So exact same commands, exactly same as you, like, basically exactly same as you install in. So now we have Vim installed. Let's check Vim. Boom, you are inside Vim. You can use anything. You can do it, other things. And just to show an example, not sure how big it is. I'll do an apt install. Let's say, like, you wanna, again, you can have, like, these dependencies, right? Yeah, everyone of us, like, have multiple labs nowadays, so they might have conflicting dependencies. Like, the first time I learned for Docker was because of that I don't wanted to, like, use multiple machines. Getting a VM inside host machine, that's very slow. So I wanted, like, okay, I want like, for we have a course named as GP. For GP we need, like, Java 11, and for the other thing we want, like, suppose Java 17 for the Java course itself. So those are, like, conflicting. Basically, I can't get both of them running at the same time. So there is where I wanted this thing, but I wanted it to be fast. So then is where I came to learn about Docker. So just suppose I want to install, let's say, GCC. I hope this is the name. Yeah, so you get like, something installed. Okay, it was fast. So I think if I do a g ++ hyphen was v. Okay, I think we need to install g ++ separately then. Yeah, it is a separate package. Yeah, so you got, like, this thing, g ++ install. So now you can basically do whatever you want in the container, I guess, basically. So you are at root. Let's suppose, let's create a file. I want to run a simple hello world program. I don't want to touch my host OS. Basically, this is another good way of preventing, basically, what you call, getting your global namespace polluted. If you install too many things on your host OS, it's gonna, like, you will feel the need to format it fast and all very soon, because it's filled with space. Your space will be used up. So you can always do it in a Docker and remove it. And the best part is you don't have to care about any dependencies and all. Sometimes you add, like, PPAs and other external repositories that might create trouble sometime. So if that happens on hostware, you need to handle it. Otherwise, you're screwed. You can't update. You can't do anything. On a container, it's as good as removing a container. So suppose I just touch a file named as, like, hello.cpp. Let's check. So yeah, that file is there. Uh, Now let's say I use Vim to edit it. Yeah, so just a very basic program, just to show, like, you can do stuff inside VM. Let's save and exit. So if we touch sorry, if we just cat it and see what we have. So we have our program. Now you can like use G++ to compile. It got compiled. If you do an ls, we should see a.out. So yeah, this is the first one. So we can just run it like a normal program. You get a hello world. So basically you are inside like kind of a VM where you can do anything without worrying about what is happening externally. And later when you don't need it, you can just get it removed. There are no issues, no dependencies, nothing, and it's way faster. Yeah, so I hope like after showing this, I answered some questions like how you can use it. Any other questions? I know it feels like it will be feeling a little heavy. In start it happens, but trust me, once you get like using to like once you start using Dockers, you won't go to VM back again. Just for the demo, I have installed this like VM manager. You can see it. You won't even recognize it. It's named something as boxes. So I've just got the most lightweight VM manager and a VM just for the demo purpose. As soon as the session is over, I'm gonna uninstall it because whatever I can do with VMs is we can do with Docker itself. So yeah,
Yeah, I had a doubt.
sure.
The container you're using right now, is it the Ubuntu container or
Yeah, is it Ubuntu? It is a Ubuntu container. Yeah,
okay? Like when I tried to install Vim,
yeah.
it said package not found.
Did you update? One issue is like once you create a container, you need to do apt update for sure. Basically, you know, right?
Okay.
Like a normal
I haven't
container.
updated.
Yeah, because it should get synced. Like it's just a minimal install of Ubuntu. So on the first install, if you don't do update, it doesn't even knows like about the repositories. What that's why update and upgrade are different. Update is it will go, it will check all the repositories, the latest versions, and it will cache it that okay, if I want these are the packages apt for getting apt, I should go here. For getting Vim, I should go here. For getting this, I should go here, like that. So just try apt update first. So again, it will like sync all the repositories. You can see, right? Focal in release, whatever is there. You'll come here, then try. Then I think it should be good enough.
Got it. Thanks.
Always. Yeah, so any other questions? Feel free to ask anything, even if you just want me to repeat something went fast because now I am used to it. I can't feel like what part is more heavier for you. Anything you want, please go ahead.
Can you run graphical applications on your conventional graphical servers like Exec?
Yeah. Who was this?
Me?
Yeah.
Another
No. I asked you because that's an excellent question. Exact question that I wanted someone to ask. That currently whatever we have seen seems to be terminal oriented, right? Everything we do is terminal. But what if we need something like a GUI? Suppose there can be two use cases. One is you don't want to like bug up with the terminal itself. I told it is replacing VM, so it should offer everything like a VM, right? So there can be two cases. Something if you want some app like suppose Blender. Trust me, you can't use it using command line. Blender is a graphical tool and it needs to have a GUI for sure. So how are we gonna handle it? Second thing is anyway exposing things. That is again pending. Like if we want to expose ports, if we want to expose, these things. Basically exposing ports, exposing your files, how you will do that. So that's the next part we'll handle. I just wanted to like give a break because like I thought it is too much. So we'll after 2 minutes we'll resume off with that. So yeah, just to answer your question, there are ways. You can even there are two ways. One is like you get an app, okay? You get an app that is accessing the display. I'll show you as you asked. Like my PC is running X server, so I'll show you the X server mapping on what you do in order to get access to the display. So basically, since Dockers are isolated, sometimes you want them to access the physical hardware. You want suppose there is a file. So what will you do? You want that file to be accessed on host machine. You have a folder. You want that folder to be available on like suppose you want to deploy a web app, so obviously you have built the web app on your host, right? Now you want it to be deployed in a Docker container, but how? There should be some way in order to get that folder itself inside Docker so that we can deploy or do anything. So that way we come to a topic that is known as like exposing. So we can expose a port, we can expose we can expose ports, we can expose this thing folders and files, and we can export some hardware like display that are we going to see. But yeah, just to mention, it's generally a bad approach to use GUI. Yes, sometimes it's unavoidable, I accept. Basically, even if like normally if you're using it locally, but since it is generally used for deployment, the GUI is not preferred at all. You should be comfortable enough with most things with the command line. It's yeah. So any other questions?
Here in the Katakora account, we must be using the trial version, right?
Yeah, yeah, yeah. And you just have to sign in. Its trial is fine. And you can like I shared the link. I hope you have it. Like the link was there. For me, it wasn't working, so I switched to a different thingy. For you, it should work. Not sure for me why the Ubuntu Playground was not. So I just switched to another course that gives a VM. So just in order to like you know figure out the issue. You saw right, it wasn't pulling off on one thing. God knows.
Yeah, I saw a plan where the
No
had
need for
asked
that. No
for
need for
a.
that. It's actually a very good platform. You can also learn like stuff if you want to like suppose learn something extra. You can always come to Katakoda for learning as well. So if I was just to show, like it has many courses. So you can see Docker. Now Kubernetes is an advanced thing. Docker management. So this is advanced management of that. You can have machine learning courses. Sure, most of you are interested learning about Linux and operating system. And basically, you just the best part is you can get a VM. The main thing for having it was like you can just get a VM without thinking about anything. Just go to the playground. You have it everything. And best part is you have something exposed as well. Basically, you can have like a GUI and all that you can add. So you can see here, like you can add a terminal or you can select a port also. Suppose you expose something on port 80 of your host, like Docker container is running. Some web app you started at port 3000, you want to access. So you can do that also here itself. So just you can select like the port to view on client one. It will open a port, enter the port number and click on display port. It will show you what is running. Will we be using this as well in some time? Yeah, so any other doubts? Cool, then let's get to the next part. So port thingy, I'll be showing you with an example because we will be like getting a full port exposed where the things are running. For now, I want to show you how to expose file. Not sure if I can do it here because it's again a VM, so I think I should be able to. Yeah, so let's suppose I create a folder. This is my host machine. You can see there's no root and anything. It's just a dollar symbol. So like I'm come out of the Docker container and you might even see that Docker PS. There is a container that's like running internally. So let's suppose basically I want to create a new container and I want something to be mapped to it. Basically, I want a folder to be exposed from my host system to that Docker container so that I can use that files for anything. So basically, if I do an ls, I am at home currently. I'm going to create a folder. Let's suppose my dir, just to name it, cd to it, and I just sorry, I need to create mkdir. My bad. So mkdir my dir to create a directory. Now going inside this, and let's say I'm just creating a very simple text file. So basically touch, let's say something like hello.txt. So we got that file created. So if now I want to like dump something to it, and just to show if I cat it, we got a hello here. Now I want this directory to be available to a container that I'm going to start. So how to do that? So everything is very simple in Docker. You just have to know the flags that you're going to use. So I'm using the same command. I want a different container this time. So docker run -d -t hyphen name, exact same thing. This time let's name it file container. Just to mention it, we are going to expose a file. Now what we're going to do is use the -v flag. So this is the flag that tells you that, okay, we want to map some folder from our host operating system to a folder that is present on the Docker container. Now, yeah, pay attention. This is important part. Whenever you are mapping something, you write it in the way host basically and is to the Docker. Basically, the first argument that you're gonna give is like map this of the host to the second argument after the colon this of the Docker. Even if you're like mapping ports, if you write for ports you would use -p. I'll show an example, but just suppose you write like 8080 is to suppose something like 3000. Always whenever you are using a colon notation, the first argument stands for the host OS. You are telling on my host machine, get the port 8080 exposed to the Docker containers port 3000. So whatever is running on Docker, inside Docker, at the port 3000 is easily accessible at the port 8080, on your host machine. So if we want to map the file here, we need to provide a path. So basically, let's say /home. This is for this machine, basically host machine. So I want my directory mapped to /home. Let's say doc directory, just to mention that it is a Docker directory. That's it. So this flag was good enough to expose a folder in your home, like my directory, and get it mapped to home Docker directory inside your Docker container. And just after that, you just mention your same thing, like Ubuntu is to whatever version you know. I stick with Focal. I feel it's more stable. So yeah, you got that container. So now if you do a Docker PS, you can see the file container is running. So you can again connect to it, Docker exec. Make sure to use the -it so that you can interact. And then basically file container is the name. And then thing you want to connect to is bash. Yeah, you are inside. Now I'll just clear it out. Yeah. So if you see, we can go to the home folder. We have a directory known as doc directory. And this directory is basically, just to understand, it's not a copy. It's a mapping of your folder, from the root folder to this folder. Basically means both of them are like sharing, both of them are accessing the same location. So if you do a change on one of them, if I'll show you inside a Docker, if I make a change to this folder, it will be reflected outside as well. It will be reflected outside to the outer world in your host OS. Yeah, one more important thing is, since you are always on root privilege, right? You can always see, as I explained, we are always on a root privilege inside a Docker. So whenever you are creating something, by default, it will be created by the root privilege. So it will be with a root access. If you might get errors that the owner is root, you can't edit. So that's why there are two ways to go around this. One is like basically do the simple work here, like inside root, do whatever changes you want, and then go to your host OS, change the permission to like a user from the root chmod 777, as you might know, and then get that file working. Second other way is any change you make in the host, as I told, both are interconnected. So even live, if you make any changes to the folder doc directory from your host OS, Docker will be able to see that. So the best practice is have whatever files you want to edit, have it open in your, basically the host machine, edit it however you want, deploy in Docker. You come here, you just run it and check, is it working? Is it working? Having managing dependencies, leave it to Docker. Editing you can always do in your like host machine. So if I do a cd to doc directory, just a second. Yeah, okay. Yeah, so first question, like we have done to like exposed many things. So any questions so far, like till now?
Could you please repeat the command, like show the command again
Sure,
to
sure,
link
sure.
the.
Let's remove the container and try again.
Thanks.
Yeah, yeah, sure. No issue. So I'm gonna do a Docker remove. First, we need to stop it, obviously. It should be stopped before we remove it. So Docker stop file container. And now I'm gonna remove it. So Docker remove file container. Yeah, good. Now, slash home slash my dir. It's the path. Okay. Yeah, so basically the command was everything is the same thing. So Docker run -it, sorry, Docker run -d for the detached mode so that you can connect to it later. -t to get the terminal name like mangled up again, basically so that you're able to differentiate you are on host or what. Name whatever you want. Let's say file cont. So this is the name of the container that you'll be running. For two things are for port exposure, you can do -p. Although I'm not using it, I can show it. Like suppose I want to expose my host VM's port 3000 to the port 80, of the Docker machine. So this is what I'll use. It's always in the form host is to Docker. We read it as expose this port of my host machine to this port of the Docker machine. So I'll say expose the port 3000 of my host machine to Docker machine's port 80. Whatever is running on Docker's port 80, you will be able to access it on port 3000 on your machine. And then for files, the same thing, you just have a different flag -v and you need to give path. You might face issues in VM though, like currently you are running on these things, they use recycling. So you might have any, like here you might like map it, you don't say it, it's fine, it's fine. If you will do it on a normal machine, like I have all my labs and all associated with map files, there won't be an issue. So this is the path on my host machine that, okay, I want to map like /home / my dirs to something like /home / let's say doc. So basically map my machine's home my dir thingy to the home doc thingy of the Docker container. So your home my dir, whatever is will be taken, and that will be mapped to your /home /doc. So everything inside this my dir will be exposed in doc. And just you have to mention the image name. So Ubuntu is to focus. That's it. So you got a container. Again, just connect. So Docker exec -it for the interactive terminal. The container name is file cont and bash to connect to the process. And you are inside. Again, you can do, cd home ls cd doc. So basically you got that folder, right? So this is how you do it. You just have to remember two flags, -p for mapping ports, -v for mapping files. Always the order is going to be from the host machine to the Docker machine. What from the host you want to be mapped to what of the Docker.
Got it.
Cool. Yeah, so since I have showed you these things, let's answer the other question now. Basically, the like currently whatever we have seen, it might be a little difficult to follow because everything I'm doing it on terminal. So it might feel like do we need to know so many commands and all and stuff. So I'm gonna show you two ways of having like showing the power of Docker that it can replace VM in every way. First of it all will be I will be showing you a live VM that is running inside a Docker container. So I won't be doing it here. Not I'll be showing it on my PC. You can follow there, but just because I have the image pulled and it's like a big image, so I'll do it here. So basically, what we're gonna do is you need. Okay, let's show you the image that I'm gonna use. It's named Ubuntu Desktop LXT VNC. So let's see if we can find something. VNC. So always, whenever you are stuck, the best friend is your documentation. You can always search upon something and you'll get to know everything. How is it working? What is there? What isn't there? And for any image, if you're gonna use it, it's better to just go to that image on Docker Hub and have a look, because they will see they have so many documentation. You might not be using most of them. So what we're gonna do is we're gonna get a full desktop environment, and it will be running inside a Docker container. So you can see like these, and you can even find some commands that they tell how to do it. You can use authentication in order, so you can get everything set up. It's completely up to you. You can even get sound working on that. Not You might not be using it, but yeah, even you can get your display. Basically, you can expose anything that is there on your host machine. So now currently we are exposing display. You can also expose your speaker. So that is also accessible by Docker. So what I'm gonna do is, basically you'll first need to pull this image. Also, one thing to mention, if you are you don't always need to pull an image before creating a container. So what you can do is you can directly use Docker run. What it is going to go, basically it will check, okay, I want to create a container for this image. Is this image available locally? If it is already downloaded earlier or something, it will be there. That means it will be accessible there, no issues. If it is not, then basically it will automatically go to Docker Hub and check that, okay, is that image available there? If it's there, it will automatically pull it for you. So let's do it. So I'll be using Docker run. Here on, it's running on port 80. Like if you see this, they basically have the mapping of 80. So it's running on port 80 for them. So the server first is like which port I want to run it on my PC. Let's suppose 6080 is the port I want to run. Second is the port on which the app is running in the Docker container. What port of the Docker container you want to expose. So since their display server is running on port 80, you can do it on port 80. Now this is a file mapping. This is just like a requirement for them that they communicate, both of them communicate whatever is happening in the dev environment. You are using GUI, right? So whatever is happening in the GUI environment, that communication to the Docker environment. So basically you need something. So what they use is a shared file concept. So they are using a folder named as SHM. So what you are doing is you are just mapping both of them. That okay, whatever is the dev SHM, you don't need to know this, like it's there in the documentation. You just read it and you get to know that they are using it because they have made the package. So what you are doing is just mapping the same folder for both of them. So Docker, if we are host OS, you do something on the browser, it will place that whatever change is there, it can communicate by placing it in that file. And since Docker also, it's mapped to the same thing, /dev/shm, you can, like Docker comes to know about it, that okay, this has happened, I should respond to that. So it is used as a way of communication. And then what you have is like you name the package, it's too long actually. So it is like /ubuntu desktop lxd vnc, and I am using the version focal. As I told, it's always stable. If you want, you can always give a name to this basically. So yeah, let's name it also, I forgot that. So let's name it, say, full GUI, and run. For my case, the image I think is already will be available on my host machine, so it can directly like create. So yeah, see, basically as soon as you created the container, it started its server and it's done. Basically, it has started its server and it's running on the port. So now if we were to go to our local host to check local host, so we exposed 80. So is 80 gonna work? What do you think? Is 80 gonna work here?
It is on their side.
Exactly. Yeah. So that I just wanted to differentiate that. 80 is on their side. If you go here, nothing you're gonna find. You have export is your port, that is 6080. So you are to go to 6080 to access the port 80 that's running onto. So give it some time. And boom, you are inside a VM. It's nothing. Just the desktop is different because it's using a lightweight desktop environment so that you feel the speed. It's just as good as a virtual machine. You can do anything. You can install stuff. You can open the terminal. Do anything. Your call. And even you can run GUI apps to answer. So let's do an app update first. Always update first so that you get synced to a repo. Basically, it updates all the packages that are there that you can use. And we are just gonna use a very simple app that is like the most lightweight, that is gvim. So if you want to use like graphical vim, so you can just do apt install. Vim GTK3. It's named as Vim GTK3. So yeah, that's it. Let it install. So this is another use case. You can even use Docker as a VM. It's not a good idea, obviously, but yeah, if need comes, you can always like say it's. You saw how fast it is than setting up a VM. A VM that I booted to show you the example took more time than setting up this whole thing and getting in here. So you can always spin it up. It's an isolated container. Whatever you do remains here. If you fall into any issues, anything, you can just remove the container, start off again. No issues with that. You can experiment as much as you want. And the best part is it will be gonna be fast, lightweight, responsive. You're not gonna feel any system lags and all because of that. Yeah, now let's run GVim. Boom, you have GVim running. So any GUI app. Now you can run Blender also, no issues. You can go create files, install stuff. Everything is you have the full GUI access to this. And just to make it sure, like you might think like, is it exposed somewhere or something? As soon as I stop the container here, as soon as I stop the container here, it will take some time to like stop the server. Okay, I came to my terminal. As soon as you refresh, it vanishes. It's running completely inside of Docker container. As soon as the container is stopped, it's gone. It has no dependency, no conflicts, nothing with your host OS. Yeah, so any questions till now? And just to mention, this is not the only package that you can use. This is one of the most lightweight that I have used just to show you. You have multiple. So if you will search for GUI packages, you can get many of them. Although this also gets all the work done, basically. Yeah, so any questions?
Yeah, and I had one doubt that
Yeah,
we are creating multiple Dockers
yeah.
containers, and afterwards, can we give a interface like from one Docker there must be it must give a output, which is an input for another Docker container.
Yeah, that comes to the advanced part of networking, as I mentioned. Basically, what you can do is to establish communication, you can create a thing called as a pipe. So basically what it does, it is just a way to pass messages. It's just like normal life what pipe will do. It will pass water from one side to other, right? So just create a pipe containing the two containers. So whatever one container does, you can easily go to like, basically get it done on the second container. Other simple way which you could think is how web applications work. So basically you can expose a port. We saw, right, we exposed the port 80. So suppose you are running something and you want the output to be available somewhere, so just expose it to a port, get a server running, whatever output you want, listen for request. So another Docker container doesn't need to know anything. It can just send a request to some port that will be automatically mapped to the port that the another Docker one is. That will get the request and then you can get it running. So basically exposing two ports and sending one request from one port to the other. As we do in web apps, we can like we design APIs and then we query the APIs, right? Same thing we can do here. Does that become clear? Like any other thing you want to ask?
No, no, nothing else. Thank you.
Cool. Yeah. So any other doubts?
So these containers are volatile, right? Like after we shut down,
No, they're gonna be there. You can stop it. So if I do a Docker basically PS to show you, nothing is running. But if I show you Docker PS-A, all the containers are still there. You can just stop and start them as you can see how many containers I have. So this was the one we created last time, full GUI. It has just exited, as we can see, 3 minutes ago. So anytime you want to start it again, just go ahead, docker start. That's it. Docker start the container name. What is the name of the container here? It is full GUI. Yeah. So full GUI. Done. Everything remains as it is. So now if you do a docker ps, you can see, right, whatever is there, the port mapping also it's shown here. And yeah, your server is up and running again. So if you refresh it again, it will take some time because it needs to start the server, but you will again, like, get the same thing working. So once you do it, it's done. You just have to do it once, start and stop the content. See, I again have access to it. Again, I want to exit it. Just we can, like, docker stop, the same thingy, basically full GUI. Done. The server is like disconnected. If you refresh, you get nothing now.
So
Cannot.
can we only close the port without closing the Docker, the container?
No. If it is running, it's just like you need to shut it down. It's just like a VM basically. While running, you can't modify like you can't change the things that it's working on. So you need to shut it down, then change, and then come. The only thing is whatever you have exposed, it's dynamic. So if you have exposed a folder, any changes I make in any one of them, like, any change you make in one gets immediately reflected to the other.
Okay, so the port can't be closed while
Yeah,
using the
yeah.
container.
You can't do it directly. Basically, you will have to shut it down, then change it, and then basically do it that.
Okay.
Because Docker containers follow the micro architecture behavior. Not sure how many of you know, but like single service principle. What they want is just use one container should only handle a single thing. That's it. It shouldn't be used for multiple things because you can create many containers, right? I showed you how many containers are there. I can't even count these containers I have, and all of them were running parallelly at once. So since they are so lightweight, you don't need to worry. You create one for this. Like if you wanted a GUI, just create it for this. So they told that it doesn't make sense to change the mappings and all in between because you are having a mapping only for one thing. So if you wanted a server, MySQL server running at port 80, you will have a container just for that thing. So as soon as you want to free that port, you don't want the server, stop the container, makes the job done, right? Because it's only a single thing that it's handling. It's not going to stop everything. And that is the main thing that makes Docker, basically scalable. You can run in VM, you can't run like more than 4 or 5, however high your memory is. My system currently has 20 GB of memory. I can't run more than 5 VMs in parallel. Docker, you can run 100 containers in parallel, and trust me, you won't even feel that your system has got even a bit of lag. Because as soon as something is not working, it is occupying no resources. As soon as it needs processing power, it takes it, scales up, does your work, again comes back to the low state. Hope it answers your question.
Yes.
Yeah, so any other doubts?
I had a doubt.
Yeah.
So, like, can we create containers for like a particular application?
Yeah, create it for each task you have to do. Go even on the minute level, like everything. Suppose you have a web application, okay? You need a MySQL connection.
Okay, here, okay, right now,
Yeah.
we're creating containers for let's say services or something. Let's say I want to create a container for a Windows application. Would that be possible?
Yeah. So again, you can refer to Docker Hub for that. Suppose you want a container that's running one application, right? We will saying like we have Ubuntu, so it's a generic thing. I have to go and install and get things running, right? So you can always go to Docker Hub and basically check the images. There are specific images for each of them. Like these are the general ones I showed you because this is easy to follow. You're used to it. You'd also have a Postgres thingy. So basically that's just Postgres SQL. You will download this image. It has no desktop environment, no nothing. It's just handles Postgres. So you just expose it to a port, get it running. Second is again an Nginx server. So Nginx server is again just a server. It is only made to handle Nginx application. Deploy it, forget it. Same for Python. It just contains Python. You won't find any Ubuntu, nothing. So if you're using a Python, just create a Python container and just like get your files ready and start executing. Nothing to worry about.
Okay.
So you have it for everything, even just test programs you have images. So whenever people install, they always run hello world in order to check. I hope the VM is done, so I can just show you the installation fast. I hope not the same issue again. It has updated, I guess. And is once you will start using Dockers, and initially it might take a little time, but it is way faster. You can see I clicked on a application. It's taking way longer than it took me to create a container and get the whole server running on that. So they become like, and my RAM is not an issue. It is 20 GB RAM and my host OS is Arc. So Arc Linux is very, very efficient in such manner. Which will be hardly using 2 to 3 GB even if I'm doing heavy work. Okay, let's try again. So this was the installation part basically. If you want to install, although even if it doesn't work now, you can just like, you just have to follow these things. I wanted to show it, but if the update is an issue, then we'll see. Okay, I came too much. Yeah, so we updated this. We now need to get basically these dependencies installing. Okay, finally, cool. Yeah, so basically you need to get these dependencies installed on a machine. I wanted to show you this because it's not just installation, it's like 3 steps that you should do. The first step for setting up on this thing is installing, obviously. Second thing would be basically making it start at, basically you should start the Docker service. So either making it like starting it locally or enabling it so that it starts on every boot. And third is like once you install Docker, it needs a root privileges, right? We saw each container is running with a root privilege. So for that root privilege, basically, uh, since it is a root privilege, it will always need you to use sudo docker. That becomes annoying. So basically, you can trust the application and add it to your user group, telling this is a trusted application. Please allow it to be executed, and you can directly use Docker. This is done. Now this is to add the key so that it gets access to the Docker repository for installation. Yeah, done. Now what you have to do is basically echo and tell the repository which basically version you want. So by default it's stable, you don't need to change anything. It is getting the stable version. It's always preferred to use stable version for some development work. Now you just get apt-get update since we updated the repositories. Anytime we update repositories, we must update in order to get access to that. So sudo apt update. And then we just have to install Docker from here. And the installation step is done as soon as we do this. Yeah, so it might take some time depending on network speed. Once you are done, you can find this thing is actually, many people don't notice that because it's very small. This is what you should follow always: Linux post install. That you have installed it. Now the configuration you need to do. So starting it, stopping it, and then getting rid of the sudo because it becomes annoying, and checking if your installation was completely successful. So as I mentioned about the hello world package, we'll be running that as soon as we are done. Yeah, meanwhile, if you have any other doubts, please feel free to ask. It will take a little bit of time to install, I guess.
Yeah, actually, I had a doubt, but it's not related to this. But it was in Arch Linux when I tried to install, I just got it as a blank thing with only a terminal. So, is there any distro of Arch which is nice?
Oh, okay, okay. Means you want to try Arc like with
Yeah,
a
I
little
wanted to
advance. Yeah.
install Arch Linux.
So two things are there. One is like Manjaro. I don't recommend it, but it is the easiest. Basically, it will give you everything that you get in Ubuntu. I hope you have. You might have heard about Manjaro.
Yeah,
So one of them is that. 1 second, if I could just switch out, I'll show you. Where is that? But it is not stable, and it uses modified version of Arc like it uses modified version of normal Arc Linux. So Like I don't recommend it, although it is the easiest. If you want to get started, it's better to like go ahead and try.
Okay.
So
And
this is Manjaro basically. So I'm not sure if they have images and all. Basically, because it gives you everything. You as soon as you start, you have everything like Windows basically, not even like Linux. I just that's why I wanted. Yeah, see, you have a bar on the down, everything showing up, everything is there. So this is the basic. Another one, if you are like ready to spend some time and learn properly Arc, but with a basic install, the best I would recommend is Endeavor OS. So this is the best Arc distro that's currently available in the market. Other than like if you want to get it easy, first off, the best thing like installation is a pain in Arc, right? That as you told, basically you have to get a terminal, configuring time also from basically just this thing. What do you call?
from the
Configuring time
terminal.
also from Arc. And yeah, main is the dependency issues. Every dependency you have to take care of yourself. So that is surely a pain. So you can always go ahead with Arc, like Endeavor OS. And it has a very good community to support. Like it has documentation so proper, you can find it for each like laptop. Okay, I have a Lenovo 320 for this, these are the issues and this is how you can solve it. So you can always try this. And it has Calamio's installer, so it is again GUI like normal. It will be showing, giving you like everything is graphical, you don't need to do anything. See, so it will start like this, you can choose off stuff and you can get doing with this. Its installer look like this as normal. You have to choose everything and it will install it for you.
Yeah, okay, I understood. And which was the distro which you are using currently in Arch? It is Endeavor.
Mine is like modified version of Arc. You can say I have Arc, like I have vanilla Arc installed, but for some packages I'm using Endeavor packages because I don't want it to build them from scratch. Like the update manager is from Endeavor itself. I've just cropped it and like using it in mine because I don't want it to do it from scratch.
Okay.
So, but the install was vanilla Arc, but there's no difference. Trust me, both of them are exactly the same.
Yeah, okay, I understood.
No
Thank
issues. It's just like a GUI, and actually, I'll prefer this over Arc because you don't want to like struggle with dependency issues. You want to struggle with the usage issue, like how to use it, how to get things working and stuff.
Yeah,
Yeah,
I
so
got it. Thank you.
cool. Yeah, so you got it installed. Now, if you see like sudo system CTL status docker.service. So it's just like system CTL is the system processes manager. You want to see is the what is the status of the Docker service. Docker service is active and running for now, but when you will restart the PC, it won't be. So there are two ways. You can like if you use Docker very like me, if you are using it every day because all of my labs run on my Docker containers. I don't have anything on my host machine. So you can enable it. So on each restart, basically Docker should start automatically. Another thing is like if you just want to enable it for one iteration, you can use enable. So the commands only differ by one thing. So sudo systemctl and at the end docker.service. If you want to start it just for one instance, you don't want it to automatically start, you start. So that will just start it for like the current session. As soon as you restart your PC, you shut down, it's gone. If you want to like don't start every time you want to use, you just use enable. So it is like again a startup program, added a startup program. So yeah, enable. Now every time you start your PC, it's gonna start with the Docker running, so you can directly execute command. Now if I check like suppose Docker, it's working, but if I do something like just suppose Docker starts, I get a permission denied error that okay, the Docker daemon cannot connect if you don't have the permission. Because I told it should run with root privilege, I'm not using sudo. Again, two alternatives, you can decide based on your own. You can either use sudo docker everywhere, that's very annoying because most times it will start asking password and all. So this is here, it got run. Or other thing is what most people do, and I have also done, is adding it to your this thing, basically adding it to your user group. Just telling Docker that okay, this is a trusted application, allow it to execute with root privilege without using sudo. So there are just two commands, nothing much to be done. So creating the Docker group, most likely it gets created nowadays automatically by Docker, but just to check. So we can see Docker is already there because it already creates a group for handling Docker. Next thing is just adding user modify, add Docker to the group of user. This command means exactly that. Change permission for users, basically add to group Docker And to which group it should add? To $user. It's an environment variable that refers to the current user that's accessing it. So I think it got executed. Or wait, I'll try again. Yeah, so it's done. Once this is done, you just need to restart your machine once, and boom, Docker is set up completely. You can just start using as we started in Catacode. I'll just restart it once to show it off. Meanwhile, any doubts, you can go ahead and ask.
What's the security for the container, since we are giving access to the files and also it starts up every time we start up the system?
Yeah, so all of them like are well tested and secure. If you go there, Docker itself has a verification portal for itself. So if you go again to Docker Hub, most of the images are verified by that. Just a second. Where is
so
that?
the container is only accessible through our system.
Yeah. So one, that is not accessible. Second thing is they're not gonna do anything that's undesirable. Like it is a conflict if I actually tell. Some people tell no, I shouldn't expose, I'll use sudo, your call. Or you can expose. But this is one sure thing. Until you make an error, Docker is not gonna make any errors for you. If by mistake you give access to someone to a Docker and he's able to execute something, then only it can happen. By default, any Docker container and any image is not gonna do anything malicious to your PC that is gonna damage and all. You yourself saw, right? The container itself doesn't like, it's just like basically what you can say, it's just like a file. As soon as you get you want to get rid of it, delete it and get a new. It doesn't even takes time. And all of them are verified. See, they are log4shell CVE not detected, so they have checkups for each of them. So all the official images where you find this green official tick tag, you can use it without any issue. For sure they're not going to do like make any harm to your PC, whatever are the official images. Users can also push images, so that you should be a little careful and make sure, although generally it doesn't happen.
Okay, thank you.
And like for some people are way involved in hacking and they are like they feel it's very vulnerable and all. No issues, you can always use sudo docker if you want to. You can even like one more thing you can do, right? You can directly gain the super access as sudo -s. What it will do, it will automatically like get you to the root mode. Now it's easy, right? Do whatever you want. So now you don't even need to enter password, and once you are done, just exit. You again come to user privilege. That's another way you can handle it. Yeah, so now if you do docker, like we enabled it automatically, right? Let's check if it's running by default when the system started. So sudo systemctl start, sorry, not start, status docker.service. Let's see if it's automatically restarted. Okay, yeah, so it is. It's active and running. We can see it. And now let's use the command itself. So, and earlier we were not able to do directly docker, what was that? Stats. Let's check if it works. So yeah, it works because you added it to the group. You restarted your VM. Now it's as good as doing whatever we done on Katacoda. Use whatever you want. Docker -v, check the Docker version. And if you want to check, like this is a very common way. There's a package known as hello world. So it is just made to check your Docker installation. It does nothing. It just checks all the things by sending requests and let you know if it's fine. So see, as I told, it is not finding any image locally. We just now installed it. It will automatically pull it from Docker Hub. You don't need to worry about that. Pull from Docker Hub, installing. Now it got it, and like it will execute it and show you the output. Yeah, so this is the output. Wait, I'll make it small only. Hello from Docker. This message shows that your installation appears to be working correctly, and they tell all the steps that it did these all steps to check your like everything is working or not. So yeah, that is all about your Docker installation. For any other OS, like if these things like Mac and all, you already know it's very easy. Just pull it to the applications folder and stuff. So you can always Google it out. And later, if you have a problem, you can text me if anything goes wrong. Okay, we are running short of time. Never mind. Any doubts till now? No, okay. So yeah, now I want to show you the third why I told you. Basically, I'll try my best to do it on Katacoda itself so you guys can follow because I want you all to see this. Not sure if, okay, it expired. Yeah, so if you leave it like for some time, it's not there, then it automatically expires. So you can just refresh and get a new one. So what I did is before the session today morning, if I go to my Docker Hub, I created a custom image and pushed it for you guys. So here what I'm trying to do, where is industry using it? I showed you a meme, right? That basically it's working on your machine, then yeah, let's ship your machine because they know that it's not working on another machine. So this was always an issue, works on one machine. Even now you will be having some issues. I remember in hash code, basically people came with the Docker installation issue and like they had many issues to get it running. And on one command was running, other it wasn't running. Like basically they were trying to run an app on a local host. One was using Windows, one was another. So it was creating issues. So it is always an issue, like it works on one machine and doesn't work on another machine. So this will like give you a feel of what power Docker has to offer and why you should use it. Once it's running at one place, you can make it running on any other machines throughout your friend's PC or anything without wasting any time in installation. So the image is named Docker session. I'll just copy the name and never mind, I'll type it out just so that like you can copy it. So yeah, Garuda is also, yeah, it is also a Arc cleaner. Like it also runs on basic Arc. It has some like new technologies you can use. I personally use it, but I found like it's a like, lot of bloatware. Like it has too many visual components just to make it funky and seems heavy. So I always like my host OS to be like as light as possible, so that basically you can focus your PC's strength and all on doing the work you want to do, not on running the GUI. Like you can see the GUI here also is there. Like if I just minimize, it scales up, it comes down, and then you have a dock. Everything has like what you call basically uh, blur effects and all, but it hardly uses like 50 MB or something. So it's better to like set it up yourself, whatever you will be using, and using that. In my personal opinion, it matters. Very people like it, so you can always use that. So it's Docker session, yeah. Just to mention the tag, if you don't mention anything, by default it's latest, but just I'm mentioning it. So you can copy this name and yeah, so let's check Docker version up and running. So what I'm gonna do is first I'm gonna pull the image. So Docker pull. Please follow along if you can, because this thing you will feel the power of Docker yourself. You'll see something in front of you. Everything else was showing. You'll get something here. So it was Docker session, I guess, and latest. So you can just copy. I'm just typing it again. So it will pull the image for you. So yeah, with this I also mentioned like you can also create your own images and pull, push to basically Docker Hub. This is my own image. You can see the name associated with the user. So you can always create your own images and ship it off, and then anyone who wants to use your image can basically go ahead, download it, and get it running as exactly as you want. So it's gonna take little time. Cool. So we got the image. Now what we gonna do is we wanna run it. So Docker run -d. Actually, yeah, if you directly want to switch to the terminal of the server, just in case that you don't want to keep it detached, and then again use exec to connect to it, you can directly use -it here also. So what it will do is it will run it and it will automatically shift you to the shell that is there for basically the container. So what it will do, you will see as soon as I execute the command, I'll be shifted to the shell inside the server. So Docker and -it. The port mapping is, this is my personal mapping. So I have exposed port 3000 on the machine and we can map it to something. So always host, I am exposing the port 8080 on the host machine. Basically, we're going to view it from here on port 8080, and the port inside the Docker is 3000. So you can change this 8080 to whatever you want, but keep the 3000 constant because in server I have configured it at 3000. So that's there. Then you can name it anything. I'll name him as web app, and basically specify the image. Okay, the auto completion doesn't work here. It makes it a bit more to type, but never mind. Yeah, so we are just running it, getting an interactive terminal. The 3000 port is being mapped to 8080. Name is web app. And Aniket, I use Docker session. That is the image name. Let's run. So you can see we directly got shifted to the shell of this. So server started on port 3000. Now, if you go here, you might have already have it because you were using the Ubuntu. You have to go to like select port to view on client one, I think. And here you go to 8080 since we export 8080. Not sure how it works. It is it on host? Oh, it's on client. I think it should be on host. Select port to view on host. Yeah, it is on host. Sorry, my bad. On host, you should view like 8080 because that is exposure host. See, you got a very simple lab that I made. Welcome to the Docker session. And this is the Docker symbol, by the way. I wanted you to guys to get used to it. Many people don't know it. This is what is the Docker symbol looks like. So now the exact question is, did you ever like even try to figure out what this container is gonna do? Did you even know what is the underlying technology? You just get the message like server is running on this port number. Do you even know what is which tech stack I'm using in the background? Is it a node server? Is it an express server? Is it something? What is it? Nothing. Did you install the files? Did you get the setup yourself? Did you install node modules or anything? Did you do it yourself? Nothing. So this is why industry is using it so much. You can just get a container working in a way on your machine and ship it, and it's guaranteed to work the similar way on your machine. You can see I have everything. I have the custom font I use, the custom color I use, the logo is there, it's CSS, so it's styled, everything is in the center, everything works by default. So that is the power that Docker gives you, which none of the VMs or anything can handle. You can get something working, ship as that is it, and you're guaranteed whenever you are migrating, either you're using AWS, Linode, you're hosting it anywhere on Heroku, it's guaranteed to work the exact same way on one machine as another. So all of you got the same output, right? Nobody will be having like this image is not there, this is going out. That is why I wanted you guys to follow along. Any machine, anything. In fact, this is not even a machine. I'm using a custom VM that I got from Katakoda. Everywhere it's going to work the same way. So that is why Docker containers are so much used, because this allows you to handle any kind of, once it's working forever. You don't need to work, okay, later I'll run it, it will give an execution error, it will give that, it is gonna get working.
So we can automate the connection process and use it as a web application.
Exactly. That is what I've done. If just I was to show you what I have used, like just the tech stack. I'm not sure like about the time. Otherwise, I would like show you how I automated this. Basically, there's a concept known as a Docker file. Let's see how if time permits. So basically here, if you can go to this folder, this is what my app was. So everything is automated. Basically, I just put an image and I just made a Docker file that automates the process for me. So once I push the image, you just have to pull it. Rest all is automated. It automatically is the image you downloaded, right? I told image is like a blueprint. Basically, it lets you know what you like want to do, how your container should function, how it should work. And exactly that is the thing that I did. I'm in the image, I've myself automated, get this thing, get the dependencies working, install it, and then start the server. You just had to run it, right? You didn't even like install node or anything. You just ran it. Pull an image and run it. That's it. Docker run. Just expose the port, because yeah, it needs. If you want to see it on your host machine, it needs to. You need to expose a port. Other than that, you ran it. You don't even know what is which tech stack it's working inside. What is the app? How is it working? And you get it run. So that is how it is used, and that's why it's scalable. Basically, there's no human intervention needed in that. What happens is they have distributed computer. Let's take example of Hotstar. They have distributed computing. As soon as their load exists, they have automated everything. A new Docker container is spin up to handle load. So basically, depends on which kind of mapping you can use. Basically, depends on which kind of mapping you want to use. You can just map one user to one container. It's so lightweight, you can have 1 billion containers running, no issues with that. We already spinned how many we don't know, and it's still working perfectly fine. So basically that way you can make sure that you never face an issue. And you know that since your image was working once, even for 100 customers, if you deploy 100 containers, all of them will be working exactly the same without any issue. So crashes become, like very occasional once you start using Docker. Yeah, any other questions?
Will the one who pushed an image be able to see who pulled it and is using?
Not exactly sure about that. Let's check. I think it shows the number of downloads you have. I think so, but it doesn't show exactly who all pulled it, because you saw you didn't log in, still you were able to pull. So you can show who, but I think it shows you the count. I just want to go back. Yeah, see, downloads is showing, right? 7 downloads, 3 downloads. So it was pulled by 3 people. Since you're not logged in, obviously it can't give you like who all is pulling. So for that, I have made this repository as public. You can make it, yeah, see, this is a public view. You can have a private so that anyone who is logged in can only, pull the image and use it, and they will be logged in. So you have all that options there. Just to show again that it's using nothing of the host OS. Okay, it was on Katacoda, right? Yeah. So just to make sure, okay, where is that? So I was just showing you like it is not using the host OS for anything. Whatever you saw, like basically is running directly on your this machine. So you don't need to worry like, okay, this welcome to Docker session is using something of my host, it will screw something. As soon as I'll stop the container from here, Control C, let's see Docker PS if it's running or what. Okay, it container is stopped. Let's try refreshing that port again. Let's try connecting to 8080. You can't connect. There's no service that soon. So it's exactly inside a container. Everything was inside a container, isolated from everything. You didn't need to worry about anything. You can just go around, mess up, try whatever you want, and no issues. And the
So if
best
your
part is it, you don't, yeah, go ahead.
if your application is crashing for a particular user input and you want to debug it, so how can you do that? We won't have access to the ones who are using our application, right?
No, you can. It depends again. Some people know that their companies are gonna ship it. They don't want you to see the internal logic, right? Because they don't want to expose their business logic how they are doing it. If you
Yeah.
want, you can expose also. So let's try again. Docker ps -a. Yeah, so Docker. I'm just showing you how you can see something. I think I have exposed it publicly. So Docker start, and the name was web app. Okay. Web app is started. Let's check it by Docker PS. Yeah, it's working. Now you can have like you can connect to a process if they have started. So I think Bash server was started by me so that you can connect to it and have a look. So Docker exec -it, then I'm gonna connect to web app Bash. Yeah, so you now come to this. Now see, you are inside an app folder /app. That is the one that is running my application. So if I do ls, you have everything. The Docker file I used to build this image, the index.js file that you were seeing, all the node modules that got installed, package log, public, everything. So you can like go to public and see like what is going on. Sorry, cd public and ls. Check. I have index.css, index.html, which was shown, and docker.webp. So you know that, okay, I was using this file. If I cat index.css, you can see all the CSS that I've applied. You can even edit it, right? You can edit it on terminal if you want. I have already shown a GUI. You can edit on GUI, get done, whatever you want. But again, to mention, some of them won't expose this because companies want to keep their business logic. Because you yourself think Hotstar is earning money for its service, right? If the service is exported, then anyone with that computational capability can run the server. Their work is wasted. So many times you won't have access. You won't have any process that's running. It's internally hidden. So in that cases you can't. But normally, yeah, you can always.
Okay.
Any other doubts? I've shown you most of the stuff I plan to. Installation and everything is done. Exposing of ports, exposing of files is done. Again, just to mention, always remember whatever files you like create in one of them is visible to the other, and anything you create in Docker is by a root privilege. So many times people might get an error that you can't run no permission. You will be like, what is happening? Make sure to change the permission first. Or it's better, like if you're getting an error, keep editing on host machine. Don't get involved in why to edit in Docker. You have VS Code or something, open it up. Host machine, keep editing, keep running on Docker. Whatever error is there, you will come to know, correct it on your host machine, then run on your Docker machine, and then you can have a look. Also, like there's a very good this thing also, like if you want to manage editing and all, so VS Code also offers a Docker plugin you can directly connect to. So basically, if I just open code, so like you will have to install a Docker application like Docker, but everything like you can even use here if you like don't want to do it yourself. So it will automatically show you what all images are there, what are containers are there. You can click on anyone and get connected to it. So everything is there as well. So here is also an easier way to use it if you want. And here you can see networks also. So this is what I was talking about. Since it's a beginner course, I won't go into this, but you can create a bridge network. So I have created a network to connect only two Docker containers. That's it. You can create a bridge network to have a, like, parallel two Docker containers connected to each other, connected to something. So it's your call how you want to do it. So you have all the volumes. These are advanced stuff like the volumes, context that they are using, and everything. So you can see it here. You can just connect off, and by default, I think once you connect to it, the terminal will switch to that Docker container. I guess. Just a second. So basically, I have these many containers. Let's say I connect to this Ubuntu one. I have too many because for each lab I have a separate container. So the main reason for getting it here was like this is the best time to learn Docker. You all of you are sure to have like many labs nowadays, and managing dependency can be an issue, or you don't want to like plug it to a global namespace. I don't have much space allocated to Linux, so I don't want to install everything useless software that I know I'm not going to use and stuff. So attach Visual Studio Code if you do. I think, yeah, so it starts itself in a Docker container now. Say starting the dev container and done. You use it as you will use in VS Code on your host machine. Your terminal is automatically executing all the commands in container. So install anything, do anything, at the end dump it off. Don't even care what happened. Even if you messed it up, no issues. Start off again without getting anything working. Yeah, so any doubts so far? Okay, some chat messages. Give me a second. I'll close that for now. Okay, I think see, it is root at the rate your container name. It is inside container. Do anything you want. So without sudo, you can do apt update just to verify it's inside container. Do whatever command you want to, and see it's getting running. So yeah. Yeah. So any other doubts so far? Bruh.
I don't have any doubt.
Cool. Okay. Yeah. So since we're running out of time, one last thing I wanted to show. I know it's like getting this thing basically it's getting long and all, but I wanted to give you like everything you want in one session. Trust me, this knowledge has been accumulated after a long time. Many like top people who use Docker don't know about the GUI and stuff because they are using for general. Now you basically have all the resources. Yeah, commands will take some time to set in. Basically, if you want, I have notes for this. I can send you like all the commands and everything. When I was studying, I noted it down, whatever I taught you today. So you can refer to that. But main thing is just start using it. Once you start using, like, it's gonna be awesome, and you will never like switch back to VM again. Trust me. It only feels a little complicated in the start, but later there's no issue with that.
Yeah, and for the Docker, is there any matplot available? Matplot environment, MATLAB's plot environment.
Sorry, I couldn't hear. Can you repeat?
Yeah, for Docker, is there a MATLAB plotting environment, the matplot?
What is matplot? Not sure. Like, is it a library or something?
Yeah, it's a MATLAB library for representing 3D and 2D graphs
Okay, let's
and
check.
plotting
Not sure.
functions.
If it's there, then good to go. If it even if it's not there, you can always spin up a Ubuntu container, right, and install it in the normal way that you would use on any machine.
Okay.
But let's check if it is there. I'm curious about this. Matplotlib. Oh, not matplotlib. Lol. What you named it?
Matplot,
Matplot. Okay.
yeah.
Yeah, lib is like the Python thingy. Sorry. So you have some of the images by some people. So matplotlib, mpl docker, matplotlib. Some is by Python. Not sure. You can check it out. So if they might have one of them, like having that running. And if they don't have, like you can always spin up a container you're familiar with, and then get used to that.
Yeah, understood.
I always like basically recommend you to do that because all the other containers, like if you will open some container which is like just, let's say I am searching for Postgres, I just run Postgres. So yeah, this is an image, but the commands and all will vary a lot. You will have to set up many things in order to like get it working. So you can see you have to set a Postgres password here and like get -d detached mode and stuff. So like basically you might get a little confused this time that okay how to do it. But so worst case what you can do, you just want it to be running, right? Get an Ubuntu container. You will find at least a million guides to guide you how Postgres SQL installation and working works on Ubuntu, and just get it started in the container. And now it's exposed to your normal environment by the port exposure. You can always access it, right? Exact same effect.
Yeah. Yeah, and I had another doubt, which was means how can we give the interaction? Means like one is the output, another one will take it as an input. Is there any particular function or
No, no, no.
how can we
That is
define
what
it?
like you create a network that connects both. Hello.
Yeah, Innovation Lab, it's unmuted.
Okay. Murli, mute yourself. Cool. Yeah. So please go ahead again. Sorry, I forgot it. It's fine. It's fine. No issues.
Yeah, it was. I was going to ask. Means one is giving the output,
Yeah, yeah, yeah.
and we must take the output as
And
an
you want
input
it to
for in the
be
another
accepted by other
container.
one. Yeah. So that is done by a concept known as networks. So basically, again, as I told you, will create a pipe and get the. I told you the two approaches, right? Same thing. One of them was like basically you create a pipe, and in that pipe, basically what you do is connect both of the Docker containers. So two containers and just a message passing stream. So one output will automatically be sent to other. The other way, the simpler way which you will be able to understand, how web app functions, like web app API thing.
Yeah.
Yeah, so basically API, you can always use an API. So what you do, expose it on some port and make it as an API. A server is running inside your container, basically listening for this thing, listening for requests.
Okay.
And what you do, whenever you want the other Docker container to interact, just send a request to that port. Since it's running on your machine, it's exposed to like, okay, let's give you an example. Suppose you have port 80, right? And your port 80 of the Docker container is exposed to port 5000. Cool. So what will you do? Send any request you send to port 5000 will get transmitted to port 80, right? Because they are the same ports. It's just a mapping. So what you do, get a server running on port 80 inside the container, and from the other container, send all the requests to port 5000. So that comes to 5000, automatically goes to 80 of the Docker, and it will respond. You will get the response in your container. Like, am I able to explain properly? Did you get it?
Yeah, I understood.
Yeah, so this is an easier way. Otherwise, there's always networks you used to do. It's a beginner session. I don't want to get into that because it needs some basic network knowledge by default. So it has like some prerequisites. Otherwise, networks is how you will get going. It is again like two commands. You get a pipe to connect both of them. And that is one another benefit since you have asked. Like connecting containers is very easy. Suppose you wanted to connect two VMs. Have you ever seen it being connected? It's very difficult. You will have to enter like on the local host, it has to affect it in order to do it. Otherwise, you're screwed. On the other hand, this thing again can be done itself, like all the changes are in the Docker and still it will be reflected to the outside world. So Dockers always keep everything isolated. You don't have any issues with that.
Yeah, I got it.
Cool. Any other question?
No.
So anyone else, like any other question?
So with Windows as host, will it run the same way?
Yeah, so you see there are alternatives. You will run like if you'll search basically how to run Linux containers on Windows, you'll get many answers, and some of them like see Linux containers on Windows 10. In the underlying edge, what they are doing is they are getting one of the Linux image for sure. Trust me, they will have one of the images, Linux images, and that Linux image will be used, like a basic kernel. I told right, like basically they use the underlying kernel that's there. They can't. So if you are running a Linux container on Windows, you can't. So you will get the Linux kernel somehow in Windows, and once you get that, you can run Linux containers for that. Although my personal advice always will be switch to Linux, please. Like basically, you are all developers. Later, you are gonna use it. Trust me, the industry hires some people just for Linux work. It is like that. People fear it that much, but it's the easiest. Everything that works here is in files. So how is it to configure? Everyone feels it. Once you start using it, learning it a little, it's very like easy to get used to. So anyway, the containers and Windows generally don't go well, but yeah, you can use it on any OS. So see, they are telling you how. So see. This is the Windows container, and this is a VM container, and it is running Linux because you are emulating it using a VM known as Mobi VM. So in the end, you will be doing the same thing. So why not just switch to Linux and on the Linux run the same thing? Becomes easy, right?
Yeah, okay, thank you.
Yeah, but you can use always install doc. It's even easier. You can just get an installer exe and you can run. Everything will be handled by itself. Search that like Docker thingy itself. Install doc on Windows, you'll get an instructions. It's easy. Yeah, so I'll share the cheat sheet. Don't worry. I have it anyway. I'll just take snapshots and share. Yeah, so any other doubt before we close up for the session? Any doubt from any part, anything you want me to repeat, you can go ahead. Also, yeah, just to tell, like you don't even need to rely on someone sometime. Like even if you didn't had my cheat sheet, suppose you can just search for Docker commands. Google is your one-stop answer. Now you can like see use command line, Docker documentation, 26 command. Trust me, these 26 commands are way more than like enough. I might not know some of them because I don't use it. So finding the version I showed you, downloading the image I showed you, all the images that are there I showed you, running showed you, what's running it's explained also. Then ps-exec, everything is there. So you can always go here and have a look. Or any commands if you forget it and what it does and stuff. Yeah, so any other doubts? Yep, Googling is a very big skill. Because it's anyway very like inefficient and not needed to remember everything. You have very limited memory. You can't extend your internal memory. So it's way better to know how things work and leave. Yeah, you can conduct a workshop on that. Lol. Yeah, so guys, any other doubt? Just think about like if you have anything. We saw, just to like give you a summary, we saw basically what are Docker containers. Before that, we explored VMs. We came to know about hypervisors, that you have hypervisor, and we saw like they have their issues. They are heavy and stuff. Then we saw how Dockers are different. Basically, they go back again to before virtualization and stuff. Now the next part comes to these things basically, like how it is emulated. So you have a hypervisor and a guest running, and on the other hand, you have a Docker engine running here. And then basically we learned about containers, why they are lightweight. We saw why industry is using it, because you can get it running once is get it running everywhere exactly the same. We already got my image that I pushed, and we all of us ran that and saw it. And yeah, that's less was the commands, mapping the files, mapping the ports and stuff like that. So just the basic summary. Discord ID, okay, just a second. Myself not sure what it is. I'm not very active. Okay, yeah. So this is the ID. Any other doubts? Yeah, so if no doubts, you guys can leave off. Thanks a lot for joining the session. Hope you learned something useful in that. For any queries, you can always contact me, no issues. If you want something, you can all we can even meet up because classes are offline. Your call. You can always contact me if you have any doubts. I know it will be a heavy session because there were too many things, but I didn't want it to keep you guys on hold. Now you know everything in order to basically simply go ahead and use Docker to its full extent. Trust me, you won't need anything more than that in your normal life until you are doing it for an industry which handles or specializes with Docker. This is way more than enough. In fact, you won't be using these many things as well. All right then. Thanks for joining and thanks for patient listening.
Yeah, thank you.
Yeah, thanks a lot.
Thank you.
Thank you.
Thanks. Bye bye.